Hello everyone, I'm Jeremy, a digital creator. Welcome to my channel. Today I want to introduce how to write a Grass Shader. If you take a look at my code, you will find that it's straightforward. I didn't use any front-end framework like Vue or React because I want to make it easy for everyone to learn. Finally, I'll include a link to my code and demo in the description. You can use it freely and easily. The first step is to use three.js to create a basic 3D environment. Here, I have created a basic camera, scenes, render, and a OB controller. After preparing the basic 3D scenes, I will create a grid helper object and add it to the scene to provide a reference for size, position, and rotation. Let's start. After I add a grid helper, how can I see the result? We just install a plugin named LiveServer, and I find my index.html file and click right button, open the menu and select the Open with LiveServer. So when I click it, I can see the result. So you can see I had already added a grid helper. Next, we will create a GrassField object in Grass.js file. I had already created a Grass.js file, and you can see the GrassField object is in this file. And look at the details. You can see I also create a axis helper to the group GrassField because I want to make reference for rotation. Next, I will create a GrassField object to our scenes. Let's start. I have defined the GrassField variable here, so I can use it. GrassField. And I add it to the scene. Okay, let's see the result in the browser. You can see an axis helper here, so I add it successfully. Look at the Grass.js file. You can see I print the grass. So let's see the console. And you can see the grass here. Okay, we are all set up and ready to go. Let me start talking about how 3D grass is made. Let's take a look at the slide first. 3D GrassField is actually a particle system. In the three.js documentation, we need to look at one of the classes called instancedBufferGeometry. Let's briefly explain what this class is doing. This class actually defines the basic prototype of a particle in the particle system. We need to define the vertex position, UV coordinates, and the join order of the vertex index for a single particle. We have three arrays to store the basic information: position array to store vertex position, index to store triangle face join order, and the UVS to store texture UV coordinates. Let's start to define a plane by setting vertex position as the slide. We push this position to the positions array. We also setting the vertex join order 0, 1, 2, 2, 3, 0. We also store in index array. Finally, we're setting the UV coordinate for every vertex. So you can see every vertex have its own UV coordinate. So we also store in UVS array. Earlier, we defined the data ourselves, but of course, we can also get this data from existing geometry shapes. Once we have created the plane geometry object, we can retrieve the information from its attribute, including vertex position, join order, and the corresponding UV coordinates. Okay, we define every variable. First, this is how many particles you want to display, and the GrassField max width, the GrassField max depth, and the GrassField max height. And we also define three array, and these three arrays store positions, index, and UVs. Let's start to add some data here. So you can look the data we store in this array. Start to define grass geometry and the grass particle. We start to set attribute. You can see we already set the data to this array and we set to the geometry. So I set position, UV, and the drawing order. Let's create a material. I have already created a material in material GrassStar, this JS file. So you can look at this material. It's really simple. It just load the shader file. And the shader class is here. So you can find it in our code. It's really simple. So I can get my material from this JS file. Okay, you can see the result here. Okay. Once we have set up the information, we need to give the GrassField a material. This material must be a shader material. So let's briefly introduce shader. Let's go back to the slide. The main purpose of shader material is to use the GPU resources to process large amount of vertex pixel information. There are two type files: Fragment Shader for processing pixel information and the Vertex Shader for processing vertex information. Let's talk about their variable type. The first type is uniform, which is bridge between JS file and the shader file. The second type is attribute, which represent the property of a geometry, such as vertex information and the UV mapping and the normal vector. The third type is variant, which is communication between Vertex Shader and the Fragment Shader. You can find my Vertex Shader file here and the Fragment Shader's file here. And in my Vertex Shader file, I only use the position attribute. I haven't used UV and index attribute. I will use them later. And look the Fragment Shader. I set the pixel to red color, so our geometry is look red. There is a problem. Although we have 10,000 particles, only one is being displayed. This is because all of our particles are currently at the same position. We need to give them an additional position attribute in order for them to have random and different positions. We will name this position variable current position. So you can see the slide. When we add the terrain position, we can add to all the vertex position, so we can get the final position. We start to add terrain position. First we add Okay, let's get back to our vertex. We have to check we have error. Okay, no error. Oh, error is coming. Okay, the final position here. Oh, so many planes you can see. Only one, and make all the position the same. So here I have set the instance 1, so there is only one particle here, and I set the position 0, so it get back to the original point. So I increase to 10, and mark this. There's rendered. Okay, I reload the page. It's rendered. It's hard to debug. I want to check one shape correctly, so I change the instance to 1 and return to the position to 0. Okay, let's get back to our slide. Before we produce many grass objects, we have to reshape this plane and make them rotation, and finally translate to real position. So let's start. I start reshaping. Mark this line. This has error. Never mind. Final position. Okay, back. And I want my width smaller. Okay, it looks smaller. When we change to 0.5 and bigger, I want smaller. Okay. Okay, must flow. So you can see. So we almost there. Almost there. Okay. I want my plane smaller, so we have to move, change the setting. Okay, but it's too high, you see, because we have changed our setting to our width and height to 1, so we just add 0.5. Okay, you back to stand on the grid. Okay, this mode is good. Okay, let's see, we can check 100 and make them randomly. Okay, we haven't added to the terrain position, so we can see many of grass. So our final position have to terrain position. Oh, you can see so many grass here. Okay, let's add some texture. Okay, let's add some texture. Back to our material. Okay, when we add the texture, but you can see no result here because our shaders code not add uniform to bridge the JS file and the shader. So let's add it. I add two texture here, and this two texture looks like this, and this is max, this is diffuse color, and I have to make JS file and the fragment file communication. We use uniform variable and add these two texture here. And in the fragment shader, we have to define two uniform variable. The name is the same as the JS file uniform. When we finish set our texture needs UV data. When we return to our GrassJS file, we can see we have already set attribute UV data to our Vertex shader. But in our Vertex shader, we can't see any UV data attribute, so we should set it. And we want the UV data sent to fragment. So earlier I said when our Vertex shader want to communicate with Fragment shader, we use the varying variable. So varying. The VUV and how can I pass the data to Fragment shader? We have to at least varying the same to Fragment shader. So like the UV data will transmit from Vertex shader to Fragment shader. Okay, we can use this data now. Okay, I want my red color plane to use the texture. So let's start. We only use vector 3, so I should get RGB 3 data. assign to fragment color. Let's take a result. Okay, we assign the texture here. We almost there. And we make them bigger, the width bigger. Okay, you can see it's bigger now. The width is bigger now. Okay, let's talk about mask. Back to our slide. We talk about mask. In a shader, how does a mask work? The basic principle is that black represents 0 and white represents white. We can use an image with only black and white color to identify which part could be displayed or not, without having to set transparency to true to achieve transparency. When we encounter black pixel, we can use the shader instruction discard to determine which part should not be displayed. Okay, good. We only get the red color if the red color number is below 0.1. We discard the black color to make a mask effect. Okay, we can see the result. We finally get a result. Okay. See? Awesome. Okay, make the instance more than 1. That's awesome. Okay. And then mark this line. Okay, you can see many grass here, but we're almost there. But you can see when we in some special angle, we have this situation because our plane is all have the same direction, so we have to make some random rotation. How to? We go to our Vertex shader and add 2 function. This 2 function is about mathematics. I'm not explaining now. You can copy to use it. And we also want to check 1 is correct, so I change the instant 1 and the making returns 0. And when we want to use this function, we have to add another attribute called angles. Additional attribute called angles. How to? We go back to our GrassField file and add angles. We set the angle 45 degree first and put it to the angles. But there is no effect because our vertex shader didn't code it, so we should add some code. When we reshaping, so the second we have to rotating. So how to rotating? We have to define a rotate axis. Okay, we add a rotating axis. And how to rotate? We just call this function. Okay, we add the attribute first because we have this attribute here. So we have to add another attribute here. And let's check how to rotate it. Okay. So let's call this function. Okay, you can see it rotates 45 degrees. Okay, I can change it to 90. And you can see it rotates 90 degrees. So let's make it render. And we want it Let's see the result. So it rotates. Render angle. You can see render angle. So let's and whoa, yes, I almost there. We almost there. Okay, you can see we already add the ground here. And I let the SC helper visible. You can see look great. When we use the instant to 10,000. Wow, so many grass here. Let's step how to make grass swaying. We have to add time factor to our vertex shader. And how? Return to our GrassJS file. We have an update function. So later return to our index file. We can see the random function. There is a time parameter. So we can pass this time parameter to our update GrassField update function. So let's start. When we pass it, and when our GrassField get it, I pass this time factor to our vertex shader. Okay, we return to our material grade start, and We earlier said when our JS file want to communicate with our shader file, we have to use uniform. So we have to add a time variable here, uniform here. And the value set 0. And uniform here. Okay. If our position, final position, y number is above 0.5, above this 0.5, the vertex should be move x and z. First we move the x, and then we move the y. Angle. We haven't seen a result. Go back to our, we get 1, and then we return to 0. So you can see the grass here, but it didn't move. So we have to change the material. It's small. You can see it swing, right? Because I make the frequency higher. Because my angle is randomly, so it is a variance for the grass. This is a range, move range. So if I get the range bigger, it move large, move more. Okay. And move more. Okay, this is not my result. I want to move less. More natural. Okay? See? More natural. I'm not to explain the function here. The main idea is the time is always change, and my angle is randomly. So the time is different, so they move different. Okay, you can try your own function here. This is my function. Okay, let's make a lot of grass. And then remove the Z position. So you can see so many. It's too fast, so I have to make the frequency lower. Okay, you can see more natural. Okay, more slower. Okay, we are finished, but it is not the real wind. In the future, I will write another tutorial about head wind force. On the other hand, we didn't consider the lighting, so I will write another tutorial about how can I add some light on the grass. Thanks for watching. I really appreciate. I want to get to know you all better, so I decide to teach in English. I'll do my best to improve. If you enjoy my video tutorial, please give me a like and subscribe my channel. If you found this video helpful, please share it with others. Thank you and see you next time. Bye bye.